guys watching 35 here, pushing launch of the Falcon 9 CRS-7. And there she is.
From Cape Canaveral in Florida, this is Falcon Launch Control at T-minus 1 hour, 20 minutes, 53 seconds and counting. The countdown is on schedule for the launch of the SpaceX CRS-7 Falcon 9 with the Dragon capsule, bound for a rendezvous with the International Space Station on a 5-week mission. Launch is targeted for liftoff at 10:21 this morning. The Dragon capsule was powered on atop the rocket yesterday at T-minus 28 hours. Pre-launch activities have been underway at Space Launch Complex 40 on Cape Canaveral Air Force Station since midnight when the Falcon 9 rocket was powered on. Shortly afterwards, there was a vehicle verification check with the Tracking and Data Relay Satellite System and the Air Force Tracking Station here at Cape Canaveral. The work to begin clearing the launch pad began shortly after 5 a.m., and loading of the RP-1 fuel, a highly refined kerosene, began at 6:33 a.m. and was followed by loading of the cryogenic liquid oxygen at 6:58 a.m. The S-band telemetry and video transmitters on the rocket have been checked out, and the flight termination system checks with the Eastern Range have been completed. Upcoming at T-minus 1 hour will be a weather briefing from the launch weather officer. The launch computer's automated terminal countdown sequence for the Falcon 9 and the Dragon capsule is initiated at T-minus 2 minutes. The SpaceX launch director gives a go for launch, and concurrence is received by launch, and concurrence is received by the range control officer from the Air Force Eastern Range. At T-minus 60 seconds, the onboard flight computer will initiate the final pre-launch countdown operation. At T-minus 40 seconds, the Falcon 9 propeller tanks will be pressurized for flight, and then finally at T-minus 3 seconds, the main engine controller aboard the vehicle commands engine ignition sequence for the start of the liftoff operation. The Dragon capsule on this flight will transport a total of 5,461 pounds of cargo to the International Space Station. 4,301 pounds are in the pressurized section, and 1,160 pounds in the unpressurized section of the module, including the 1,021-pound international docking adapter. Dragon is actually capable of carrying up to 7,300 pounds of supplies to the station. Splashdown in the Pacific Ocean at the end of the mission is planned for August 5th at 6:28 p.m. West Coast time, 3 hours prior to sunset, just under 396 statute miles offshore from the coastline of Southern California.
That's what they always
Dragon will be bringing home 1.5 tons of cargo and research experiments from the International Space Station. At T-minus 1 hour, 18 minutes and counting, this is Falcon Launch Control.
Okay guys, I don't know if I'll be able to recreate this mission KSP, as the last tech has not updated his mods. Oh, what is mod? I'll try to get the Dragon into orbit once we're in orbit. Nothing changes there. If that works once, I'm just going to refresh and do it. Also, I really hope they managed to hit the barge and softly hit the barge. You can see some blocks venting right there. Oh, you can't see one. That's fish. I feel like you're watching a rocket launch. There's another one. I feel like you're watching a rocket launch and then you get distracted by a fish jumping out of the water. Damn, that's a lot of blocks. Blocks being obviously liquid oxygen. They're not pouring locks like the type you lock the door with. So I'm just terrible at this.
This is Falcon Launch Control, T-minus 1 hour, 15 minutes, 30 seconds, and counting. Joining us now here in the Mission Director Center is Steve Bigos, the NASA Orbital Replacement Unit Manager for Kennedy Space Center for the International Docking Adapter. And Steve, we'd like to welcome you here to tell us something about what the so-called IDA is and why it's so important to the station. So if you could kind of begin to tell us why this is important.
All right. Thank you, George. Thanks for inviting me. So the IDA represents the latest in technology for docking to the ISS. The older technology is about 30 to 40 years old with the APAS system. Now the IDA provides the latest specifications for the International Docking System Standard. So if you're a visiting vehicle, maybe you have a vehicle that wants to go to Mars or beyond, or an asteroid, anything outside past space station first, the IDA provides the new technology docking system.
And this is made for NASA for the station project by whom?
It's a Boeing JSC
Station project by whom?
It's a Boeing JSC NASA design. It's actually, the hardware is actually built by Boeing and provided to NASA by Boeing.
And it weighs about how much when we take it up in the module today?
It's right about 1,021 pounds.
Well, we've got a video now. We're going to show that, and you can tell us something of what's going on here to get the IDA ready for flight, and then how this interfaces with the station.
Okay, George. So this is the IDA as it was delivered to the Kennedy Space Center. On the top side are the pedals that attach to the is the attached system to the space station. Yeah, so what we're doing here in the SSPF is we had a lot of optical alignment work, modeling, and testing of the peripheral docking target. So the peripheral docking target, you'll see it coming up on the video right now with the little standoffs and the black triangles. That's a brand new technology design so that the visiting vehicles can target their range-finding equipment to align precisely with the IDA on approach to the station. In the picture here now, you can see the connector caps, and now you can see the connector caps in the front, on the front of the IDA, right below the IDA emblem. Those are connector IDA. Here's our NASA team with the Boeing and the local Jacobs contractor providers performing their digital pre-assembly to allow us to perform very precise measuring and modeling of the IDA itself. So these models, and you'll see coming up in the video in a minute what the model actually looks like on a computer. This allows the designers as well as the ISS on-orbit crew have access to exactly what the IDA looks like, very precise positioning of on the IDA that could be used for capturing the visiting vehicle. In the front of the picture there, covered up with the MLI, just to the right of the man working, that's the H fixture that the station would use to grapple. And the technician in the picture here, he's performing a very precise location with an instrument connected to a computer that allows us to perform that very precise location measurement to use for the graphics models. And here's more of the equipment they're looking. See, the engineer now, you can see on his screen, he's building up the model with some points that are located with the instruments. And again, there's the peripheral docking target. And again, this is IDA 1. IDA 2 was also delivered this week. So here's our animation showing how the IDA connects on orbit. It's already been taken out of the Dragon trunk by the SSRMS, and the dexterous manipulator now has it getting ready to approach
SSRMS?
the Node 2 PMA2.
Just delivered here to
That's
Kennedy.
right. It was delivered this week at Kennedy Space Center, and we have it in the space station.
Here to
That's
Kennedy.
right. It was delivered this week at Kennedy Space Center, and we have it in the space station processing facility right now.
And about when is that targeted to go up to space station?
I believe it's the SpaceX 9 launch.
So not very far off.
No.
You know, just a couple of launches from now.
And then that would connect to also to Node 2 to PMA 3, I believe.
Well, Steve, thank you very
Yeah,
much.
Tim.
And,
Thank you, George.
I know you'll be looking at operation as much as our launch today.
Yes.
So,
Thank you.
thank you very much. Steve Bigos, the NASA Orbital Replacement Unit Project Manager for the International Docking Adapter here at the Kennedy Space Center. And we're at T-minus 1 hour, 10 minutes, 20 seconds and counting. This is Falcon Launch Control.
As you can see, that the building to the right of the launch pad, so a bit away from the lightning towers. Yeah, you can. That's where they assemble the Falcon 9. Horizontally, it's rolled out, and then the transporter erector strung up, which is you can see right beside the LV. I'm saying this to people who haven't seen the launch before. And the transporter erector just lifts it up. I'll just try to do that in KSP. I have no idea how, but I should. Oh, there. Nice close up, you can see the grid fins on landing legs. The grid fins kind of just a bit above halfway up the launch vehicle. Oh, I never knew the valve liquid hydrogen, or I don't know if that's oxygen or hydrogen, but you can just barely make out SpaceX. And I'll see the landing legs at the bottom. Even if it fails, I can't wait to see the footage. Probably just edit that on to the end of this launch once I get the footage. Glitches, they're everywhere. Although, seriously, how do they transport this? I think they only actually transport that, and then that's always at the launch pad. But still, how do they do it? I don't see any. I have no idea. Oh wait, what? There's still locks venting, so there's quite a bit of locks there. Derp. See, I'm just going to try to recreate the IDA in KSP. But don't worry, I have a plan. That's not always a good thing if I have a plan. But it is fairly simple. And I still have no idea how to actually get the thing attached. As we have no robotic arm, now I have to use the entire station, which is no RCS just besides the thing besides the Soyuz. It will be entertaining anyways. He's back.
This is Falcon Launch Control, T-minus 1 hour, 5 minutes, 54 seconds and counting. After liftoff from Complex 40, Dragon will begin its journey to the space station. Just under 10 minutes after launch, the capsule will reach its preliminary orbit, deploy its solar arrays, and then begin a carefully choreographed series of engine firings to rendezvous with the International Space Station. At the time of launch, the space station will be located at an altitude of 251 statute miles over southern Turkey, just north of the border with Syria. With a launch today, rendezvous and grapple with AM Eastern Time. At that time, the ISS will be located 250 miles above the southwestern portion of Kazakhstan, just west of the Baikonur Cosmodrome. Once in orbit, Dragon will have a link with a network of ground tracking stations around the world, as well as with NASA's Tracking and Data Relay satellite system. For its return, approximately 4 hours after Dragon leaves the station, Dragon will conduct its deorbit burn, which lasts 7 to 10 minutes. It will then take about a half hour for Dragon to re-enter the Earth's atmosphere and splash down in the 396 statute miles off the coast of southern California.
I'm keeping my eye on those fish. Let's see if I can catch one of those fish.
Right now we're going to look at some video of the student experiments going up on the Dragon for this mission that are sponsored by the Center for the Advancement of Science in Space, the manager of the U.S. National Laboratory on the space station, also known as CASIS. So we'll look at experiments also going up on Dragon on this flight.
Oh.
Utilizing the ISS to excite and engage kids is really what it's all about for CASIS, and we think it's a great tool to get kids to think in that direction. Today, there's just so much white noise out in culture for the kids. You know, today's heroes are typically stars or athletes. We just don't celebrate the brilliant minds of the day like we did in the past. The SpaceX 7 launch represents an opportunity for thousands of students and educators to be involved in executing microgravity experiments on the space station. I would say in excess of 30 experiments are being launched, representing over a dozen different programs and partnerships that we have with National Lab. National Design Challenge is a STEM program that gives students and educators an opportunity to design, propose, and implement a real science experiment on board the International Space Station's U.S. National Laboratory.
We need to measure all compost materials, so I may need to send somebody down.
The opportunity for the National Design Challenge came. We felt that sending worms to space would be a great thing to do, since the future of space travel is to hopefully go to Mars one day, and so we want to see if worms can compost in microgravity.
And the moisture sensor definitely won't fit, but that's an easy
The students are studying, can worms compost in space? And the reason why they're doing that is they want to see if we can reduce the amount of trash that is brought back to Earth from the ISS. We kind of broke it in. Miss Atzmiller took care of biology. I took care of the engineering. So we had 8 to 9 groups of students. Every group is really proud of their work.
We're the biology team.
I am on the art team.
We do the hardware and software stuff.
We're part of the engineering structures team, so we were working to mostly design this.
We need a solder and prep the tensor.
We're expecting to learn some real science from these experiments. These just aren't play toys that we're sending to the ISS. This is scientifically reviewed, vetted, and selected research that's going to space. It just happens to be designed and executed by educators and students.
So I really wanted to get involved in science and engineering, math, and technology.
Science, I really like getting into my hands and touching dirt.
These STEM projects, they're months long, and the kids that are engaged with it are so deeply engaged. You know, I can't tell you how many times the bells ring and kids are still in the classroom.
Just telling people, I know, like, hey, I'm sending something to space. I mean, it's really cool to tell, and it's just a great experience that I was really glad I got to be a part of.
It's just amazing that we get to do something this big that a lot of people, scientists, dream of doing.
It's a once-in-a-lifetime opportunity, and to give this to the students and have them problem solve through this has been an amazing journey.
The ISS is an amazing platform. It's this bright, shining object in space. And what kids don't love the thrill of space and get excited about space? I don't know any.
I'll tell someone and they'll be like, wow, like, you're sending something to space? That's amazing.
We're just under T-minus 1 hour and counting in our countdown for the Falcon 9 with the Dragon capsule on the way to the ISS. And we're standing by now for our launch minus 1 hour weather briefing from our Air Force Launch Weather Officer, Mike McAleenan.
So unfortunately, I know people who don't really get excited by space.
This is the LWO with the 1 hour range weather briefing. On your video screen, you should see enhanced infrared satellite picture showing virtually clear skies over the Florida Peninsula. You can also see a frontal boundary draped into the northern Gulf, or southern Gulf Coast states, and also off towards the east, south of North Carolina. There is a frontal boundary in that area. It's generating some thunderstorms, and we expect it to remain in northern Florida and along the Panhandle and just off to the northeast throughout the remainder of the countdown. The cursor on that picture is roughly where the recovery will take place. So you can see they are north of the boundary, and looks like they will have good conditions. Zooming in a little closer, on the visible picture, you can see just a few clouds streaming across the mid part of the state right now. Looks like they will move to our north, and they are moving about 15 knots. Right now they are about 40 miles away, so will not impact the window. On radar, you can see those echoes. But again, they are not a concern, and it looks like they're not going to be on a trajectory with a speed or direction to make their way towards the pad anytime close to a T0. Looking at the pad, you can see the winds are nice and light, 10 to 15 miles an hour, and the direction is out of the southwest, around 230 degrees, and should remain that through the remainder of the countdown. Temperature has started to peak back up again. We are going to approach the mid-80s for T0. Looking aloft, we also have had real good agreement on the balloon and the 50 megahertz profiler through the countdown for this last several hours. You can see max winds in this scale are only 30 knots, so peak winds out there right now at about 52,000 feet are only 22 knots. So a very nice day, a very light wind, calm day. Looking at solar activity, again, another well-behaved sun, and all of our criteria well below constraints. We are go for all range weather and user Falcon 9 weather commit criteria, and expected to remain so through the remainder of the countdown. Forecast calls for just a few coverage of clouds, 2,000 feet, and maybe get a puff of Q starting up right before we get to T0 at around 2,500 feet. Good visibility, again, no change in the winds, and less than 1% chance of violation for the next hour.
That's good.
Recovery weather also looks good. They are, again, north of those showers and storms that will be to our south. Winds are about 20 knots at the surface and 5 to 7 foot seas. If we were to delay, weather does get a little bit worse as that frontal boundary drapes more towards central Florida. So get a bit more instability and more cloud cover will give us a better chance for rain showers in the area. 30% chance of violation, mostly cumulus cloud rule, like the precipitation. We might also see some thick clouds in the area. That's all I have. Any questions?
Why is there a boat there? I sense Centaurs.
That completes our weather briefing this morning. All conditions are go weather-wise for our liftoff. We're not working any problems in the countdown either, so we're on target for a 10:21 a.m. liftoff this morning. Or at 10:21 a.m. liftoff this morning. When Gennady Peralka broke Sergei Krikilov's record aboard the space station on Sunday of 803 cumulative days in space, he had completed 12,848 orbits of the Earth, which totaled a distance of 339,870,899 miles. The distance between Earth and Mars is approximately 140 million miles, so Padalka has traveled roughly the equivalent of 2.4 trips to Mars during his time aboard the space station. We're now at 55 minutes, 55 seconds, and counting. This is Falcon Launch Control.
T-minus 55 minutes. Once again, you can see a lot of liquid oxygen. I really hope they manage to hit the barge lightly. No soft land. And this time the barge is called Of Course I Still Love You. God damn mouse. After another character in then Union Banks book, the same book as the another character spacecraft, the same one where they got just read the instructions from. Here's when it's perhaps kill a vésig. Amerikai. Szóval ezek landolják a első fokozatot. Right, oh, you can see a bit of ice, I think that is, falling off the Falcon. By the way, why do you even have the lightning rods there if there's... Because pretty much if there's any chance of lightning, they're going to abort the launch. I guess it was there from the Titan era, so they didn't remove it, I guess. Although this one, most of my KSP launches wouldn't work. Because most of my KSP launches would drop kind of... Oh, bye.
This is Falcon Launch Control, T-minus 51 minutes, 30 seconds, and counting. Join us now here in the Mission Director Center is Joy Amasa. She is the NASA Veggie Science Team Lead from the... And Joy would like to welcome you here to the program to tell us what is it that's going up on Dragon this time as far as Veggie is concerned.
Thank you, George, and thanks for inviting me. So for this flight, we actually have a small Chinese cabbage that's going on to the Veggie flight. This is one crop that was tested here at Kennedy Space Center. We looked through a variety of different types of crops, and we grew them, and we saw how well they grew, and we also tested them for nutrition. And then we actually grew some more, sent them to Johnson Space Center, and tested them for actual sensory evaluation done at Johnson Space Center. And this was the crop that was the most highly rated, Space Center. And this was the crop that was the most highly rated. So this is a very small version of the plant. They'll be a lot bigger when they're growing, when they're ready to harvest.
And are there any other veggie seeds going up, or is this particular seed the one that they're going to focus on?
So we have this crop as well as a crop that we've grown previously, which is our red romaine lettuce.
Lettuce, okay.
And that was what was grown in the very first flight of veggie on Space Station.
And have we any idea yet when the astronauts will actually begin to try some of these on orbit and
Right. We're hoping for very soon. We've been, we got the lettuce back from Space Station that they grew originally, and it was pretty clean. We found typical station microorganisms on it, so nothing surprising, nothing unexpected, and nothing that we feel is dangerous. So now we've been working with the flight medical groups at Johnson Space Center and explaining our results to them, and then the next step is to get all the documentation in line for approvals for the crew to eat the produce. And so that's really where we're at. No one sees any red flags. It's just figuring out what are the right steps to take. But we hope that by the time the crew actually grow this lettuce and cabbage, they'll be able to eat it.
Now, do we know when in the mission they'll actually take the seed pillows and start growing this particular crop of seeds?
We're not exactly sure. These are what are called reserve crew time, so they're when the crew has an opportunity, they'll be able to grow these, and so it'll also be when the crew is interested. But we hope that they will be. From what we've heard, they really enjoyed growing the plants when they did it last time, and other astronauts seem quite in favor of growing the plants. So, here you can see the preparation that we did before launch. We did a lot of testing here on the ground at Kennedy, and we had to carefully test all of the different types of plants before they go up to the International Space Station. And these are the plant pillows from the very first test. This was red romaine lettuce, and so this was the first test. We plant 2 seeds in each pillow, and then after about a week, the astronaut taking care of them thins down to 1 seed in each pillow, because we overplant to make sure that the plants germinate well and grow uniformly. This was Commander Steve Swanson, who was actually the caretaker of the plants on the last flight, and this is when he's just initiating the experiment. So he has to add water to the different plant pillows after he puts them in. This is actually the installation process. He needs to just make sure there's no loose particles of media there, or anything that might come out and float away. And then this was at the harvest, and it was actually really interesting because you see there's a lot of people gathered around for that harvest. So I think it was a big occasion on Space Station. He grew the red romaine lettuce for 33 days, and that's one of the plants. Everybody was really interested. There's some cosmonauts out and some astronauts out taking photos and looking, and so it was kind of a special occasion on station.
Well, when do you expect you might get some of the plants that we're sending up this time? When might they be coming back? Do you know what flight that would be?
We don't actually know. It'll really depend on when they have time to grow them. We hope that they'll be able to grow the next set of plant pillows when they get 3 more crew members up there. So in mid-July, we hope that they'll have more crew time available and be able to start them. And so in that case, it would probably be on the next SpaceX return flight, CRS-7.
Well, Joy, thank you very much.
Thank
Joy
you.
of NASA, our NASA Veggie Science Team lead here at the Kennedy Space Center.
Thanks.
And we're now at T-minus 46 minutes, 4 seconds, and counting. This is Falcon Launch Control. This is Falcon Launch Control, T-minus 42 minutes, 30 seconds, and counting. Our launch director for this flight for SpaceX is Ricky Lim, and our SpaceX launch conductor that we're hearing frequently on Channel 1 is Brian Childers. In about 2 minutes, we will hear the commands to begin placing the Falcon 9 rocket in the final configuration for launch. This time we're not working any issues here at the Launch Control Center, which is located on Cape Canaveral Air Force Station near Port Canaveral. And we see images here of our SpaceX launch team conducting the countdown here this morning. Control Center at SpaceX's Hawthorne facility, Mission Control in Hawthorne, California, where there will be control of the flight after liftoff and through the docking together with Johnson Space Center in Houston for docking with the International Space Station on Tuesday. We're now at T-minus 41 minutes, 5 seconds, and counting. All things going well in the countdown, on target for a 10:21 a.m. liftoff this morning. This is Falcon Launch Control.
Dang, I missed much. Okay.
This is Falcon Launch Control, T-minus 35 minutes, 28 seconds and counting. Falcon 9, as we see it on the pad, is a two-stage rocket, fully designed and built by SpaceX. Falcon 9 is named for the Millennium Falcon in the Star Wars movie. The number 9 refers to the 9 Merlin engines that power the Falcon 9's first stage. Falcon 9 is designed to carry commercial and government satellites, as well as the SpaceX Dragon cargo module with supplies and eventually up to 4 astronauts to the International Space Station. On the Dragon module's manifest, in the pressurized portion of the cargo module for this mission today, are 4,300 pounds of payload, including research experiments, experiment freezers, food, crew provisions, and exercise equipment. And going up in the unpressurized section is the first of 2 international docking adapters to create a docking port for future commercial crew vehicles. And also aboard are 30 student experiments in plant seeds to be used as part of growing more efficient different vegetables for the veggie experiment, which we just heard described to us by Joy Massa, our veggie scientist. This current version of the Falcon 9 with the Dragon spacecraft is 208 feet in length and 12 feet in diameter and weighs by itself 735,000 pounds. The rocket is held down on the pad and not released for flight until all 9 engines and the launch vehicle systems are confirmed to be up and burning properly. After liftoff, the first stage will burn for 3 minutes before separating from the rest of the rocket, and then a single Merlin engine on the second stage will burn for 5 3/4 minutes before the Dragon cuts off 9 minutes into the flight and separates from the Falcon 9 10 minutes after launch. After the liftoff, mission control for the Falcon 9 and the Dragon spacecraft, as we mentioned, will be from the SpaceX Mission Control Center in Hawthorne, California. Dragon will have a link with a series of ground tracking stations around the world, as also through NASA's tracking and data relay satellite system. Weather on this countdown so far continues to be virtually perfect. And we're continuing not to work any issues. We're still on target for 10:21 a.m. liftoff this morning. At T-minus 32 minutes, 45 seconds and counting, this is Falcon Launch Control.
Okay, nothing much happening right now. Got them to us in the wrong place again. .31 minutes and counting. I wish I could say this is Falcon launch control, but I don't work at Falcon launch control, unfortunately. So I cannot say that. Still venting liquid oxygen. Presuming they're venting it because it's boiling off anyway, and they need the room to be able to be filled with the liquid air. Heck, I don't even know. Once again, you can see the construction hangar.
This is Falcon Launch Control, T-minus 28 minutes and counting. Most of our communications channels have been relatively quiet. The team has been busy configuring the vehicle, putting it in its configuration for launch, and then when we reach T-minus 20 minutes, they'll begin the final launch countdown preparations, but configuring the vehicle has been underway since about T-minus 40 minutes, and that's been going very smoothly and routinely.
That's a good thing.
We'll get the final poll of the launch team at T-minus 13 minutes of 14 console positions in the SpaceX Launch Control Center. Not working any other issues. Looking offshore, range is clear, no issues there. Weather is green, and it appears that we're going to have a very spectacular morning for a launch today. And there are many people lining the coastline this morning for the chance to see a SpaceX Falcon 9 rocket launching to the International Space Station on a relatively clear, cloud-free day. On a Sunday morning when everyone has an opportunity to go to the coastline and watch a launch that at this point is going completely smoothly for liftoff at 10:21 Eastern Time. At T-minus 26 minutes 15 seconds and counting, this is Falcon Launch Control.
OSM, this is LC on the countdown net.
OSM.
Verify the flight hazard area roadblocks are established.
They are established.
There was another fish. They were everywhere. Another good view of the landing legs and the grid fins. Another 20 or so minutes until liftoff.
This is Falcon Launch Control, T-minus 18 minutes, 52 seconds and counting. All of the various console positions at the Launch Control Center have been coming up and reporting their status for going into terminal count. And at this point, everything is still proceeding.
All the team and
go.
Everybody's good to go into terminal count. I'm reading on Dragon at this point in time, but I'm going to go ahead and move the warnings to terminal count.
Copy.
There you go.
So as you heard, all of the vehicle positions are reporting in to the chief and engineer that will go for the terminal count. Still waiting on Dragon, but our next major poll will come at T-minus 13 minutes. Dragon reaches its preliminary orbit, and it then deploys its solar arrays. It begins a carefully choreographed series of thruster firings to reach the space station. After a 2-day trip, NASA astronaut Scott Kelly and
I've done the last move again.
That all teams are good to go, so we're continuing to press on toward that terminal countdown poll at T-minus 13 minutes. Everybody reporting in so far that their systems are go. After the 2-day trip up to the International Space Station, NASA astronaut Scott Kelly and cosmonaut Gennady Padalka will use the station's 57-foot robotic arm to reach out and capture the Dragon spacecraft as they operate it from the station's cupola. Ground commands will be sent from Houston to the station's arm to rotate Dragon around and install it on the bottom side of the station's Harmony module for its 5-week stay at the International Space Station. By the next day, the crew will pressurize the vestibule between the station and Dragon and will open the hatch that leads to the forward bulkhead of the Dragon. Then, over the next several weeks, the crew will unload the spacecraft and reload it with cargo for its return to Earth. Departure from the ISS will occur on Wednesday, August 5th. After a 7 to 10 minute deorbit burn, it will then take about 30 minutes to re-enter the Earth's atmosphere and splash down on its 3 main parachutes in the Pacific Ocean off the coast of Southern California, which right now is expected to occur at 6:28 p.m. Pacific time. The capsule now also has a nighttime recovery capability if it's needed, including a GPS locating beacon and high-intensity strobe lights for optimal spotting, while the recovery ship itself also will have night vision IR camera gear. So the Dragon capsule continues to gain flexibility as we go
All
further.
personnel stand by for the final poll at T-minus 13 minutes.
Just confirmation that we will have the final poll at T-minus 13 minutes, so everything is on schedule. We're at T-minus 14 minutes, 45 seconds and counting. This is Dragon Launch Control.
You always said Falcon before. Something is suspicious.
This is Falcon Launch Control, T-minus 13 minutes, 32 seconds and counting. Standing by now for our final polls for the countdown this morning, coming up in about the next half a minute.
All stations verify, ready for launch. FTS.
FTS go.
Prop. Prop go. AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground is go.
VC.
VC go.
GC.
GC go.
RC.
RC go.
OSM.
OSM go.
ROC.
Rock go.
CE. Go. MD.
MD is go.
LD, verify go to initiate terminal count.
LD is go to initiate terminal count.
Proceeding with terminal count and countdown master.
VC and DC start the terminal count auto sequence is set to start at T-minus 10 minutes.
Terminal count is set to run.
DC countdown net.
DC on countdown.
Start the terminal count auto sequence set to start at T-minus 10 minutes.
Dragon terminal count has started.
How does that mouse move when I'm not even touching it?
If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In this event, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds, and operators shall not call a hold after T-minus 10 seconds. If a hold is called, all operators proceed to the terminal count abort steps in section 10.64.
"30 seconds from starting the automatic countdown sequence.
Attention all personnel, stand by to pick up the count. T-minus 10 minutes and counting on my mark. Three, two, one, mark. VC verified auto sequence has started.
Terminal count auto sequence has started.
GC-VC standby on FireX.
Standing by.
Standing by.
LD, start the tracking camera video recorders.
Started.
OSM set launch enable to flight.
Flight.
Stage 1 engines shelling in. Spin and T-tip final setups.
Oh, are they testing the sprinkler system there?
T-minus 9 minutes.
I'm wondering when they're...
Dragon going to internal power in less than a minute.
I'm however wondering when they're trying to strong back. At what time? I'm presuming Dragon goes into internal power, then the strong back.
T-minus 8 minutes, 30 seconds.
8 minutes. I think it's around 4 or 5 minutes, I think. I need to CRS.
T-minus 8 minutes.
9. That's the next thing.
Nitrogen ACS closeout.
What I just said is the next thing I draw will be a Falcon 9. So I'm gonna take a quick screen here. Oh no, that's the video quality itself. I just look at the NASA logo to see the quality, because you know sometimes it's, you can see it's the like what quality is being supplied to me, you know. I'm gonna take a screen. Presumably this camera's on top of the VAB. Oh god. I will be going here to watch the launch of Exploration Mission 1.
Stage 1 heaters closing out.
You know, I hope to be.
T-minus 7 minutes.
And counting. Don't forget that.
Counting. The terminal countdown is being beamed live to the International Space Station.
What would happen?
Vehicle switching to internal power.
If somebody called a
bleed
hold
stage 2 has started.
At less than T-minus 10 seconds because they noticed like a problem with one of the engines, would they still, or like, well, not with the engine, but you know, some problem, would they have to, at that point, would they be at a launch commit where they have to go? You know, it starts like, and it would
T-minus 6 minutes.
Like the problem emerges just in the final, like, in the final 10 seconds.
Tanks pressing for strong back retract.
Okay, so I was right. That
RP1 bleed stage 2 starting.
RP1 bleed. Presumably, I don't even know what that means because yeah, those are arse. No, they're ice.
Strong back should retract from the vehicle about 4 minutes and 20 seconds before liftoff.
Oh, so it's an in 4 minutes and 20 seconds.
RP1 bleed stage 1.
I'd be like, what? Okay, from the shadows, I thought they were doing a grid fin test. They're not.
We have cradle movement.
Anyway, we'll keep you guys updated on my Facebook about if it landed, but you know, you guys will probably know beforehand, but I will. I will also upload a video. God damn the mouse.
T-minus 5 minutes.
T-minus 5 minutes and counting. And my hand literally right over. How does this move when it's on a stable object? You need to press F10 to capture the moment of strong back retract.
Cradle's fully opened.
Oh! Shit,
TVC motions on stage 2.
It's already moving. Did not really change camera bit now? No? I want to go onto the live stream app so I can just watch this, see if I can...
Strong back motion.
Oh yeah, there we go, there she is. No live events. Yeah, there is, comrade. That's a notification.
T-minus 4 minutes.
Come on, not archived, come on.
Stage 2 TVC motions complete. Tanks venting, post strong back retract.
What's this? No, I don't want a thing. Quad, yeah. Yeah, they have a different camera angle on this.
Pogo accumulator vent.
T-minus. Okay, this has a bit of delay.
FTS is on internal power. FTS is armed.
Oh, cool! They actually have kind of like a thing, huh?
GNC verify good stage 2 TVC motion.
GNC confirms good stage 2 TVC motion.
Presuming that's again.
Block load closing
Trust
out.
vectors.
MVAC igniter purge has started.
Stromback fully retracted and pinned.
I'm going to
Stage 1 throttle valve setups.
Okay, guys,
Stage 2 helium fill closeout.
LD verify go for launch.
This is the LD on countdown 1. SpaceX, Falcon 9, and Dragon are go for launch.
Stage 1 tanks
I'm just
pressing
going to
for
have
flight.
that there, so I have like a
Vehicles
two
in
screen
self-line.
almost, like split screen thing. Yeah, that's almost half a minute later, so we'll get to see launch.
Stage 2 BTV check complete.
Twice, technically speaking, so I have a bit of delay. And I also have the SpaceX webcast running just in case they start showing. There's 20-second or so delay. Yes.
Stage 1 helium fill closing out.
Yep. Strange hearing it first on this and then on that.
Spin and stage step ISOs closed. Vehicles in manual.
Vehicle in manual, whatever that means. It's really strange. What's that? That's a good camera angle right there.
Vehicles in auto idle.
T-minus 1 minute.
BC and DC verify F9 and Dragon are in startup.
F9 is in startup.
Dragon is in startup.
And
Stage 2 tanks pressing for flight. Flight computer has control of the vehicle.
means we're go for terminal count.
T-minus 30 seconds.
T-minus 30 seconds. Yeah, that's 20 seconds in the path.
Pad water system armed.
T-minus 20.
T-minus 43, 42 on the other screen.
T-minus 15. T-minus 10.
9.
8. 7.
6. 5. 4. 3. 2. 1. Ignition sequence start and liftoff of the SpaceX Falcon 9 rocket, adding to the International Space Station access for future American rockets. And Falcon has cleared the tower.
Perfect. Okay, this just reminds me of the Cygnus 3.
Vehicles programming downrange.
Stage 1 propulsion utilization is active.
She lifts off rather slowly. This is the best launch I've seen, because it's not cloudy at all. Perfect view of the landing next.
T+1 minute. Altitude. Speed 290 meters per second. Downrange distance 1.1 kilometers.
Oh, vehicle is supersonic. Just make out the kind of halo.
Vehicle supersonic.
Anybody know what causes that kind of effect around the engine?
Recovery drone ship has AOS.
Vehicle's reached maximum aerodynamic pressure. Stage 1 propulsion is still nominal.
Power to motor remain nominal.
I'm experiencing a glitch with the SpaceX. Because past max Q 20 seconds ago, roughly.
Impact chill has begun. T plus 2 minutes. Altitude 32 kilometers. Speed 1 kilometer per second. Downrange distance 13 kilometers.
This is half curb and orbital velocity. Well, okay, they're going in the SpaceX. They're displaying.
Data coming back shows vehicle on course, on track.
Whoa! What was that? What's that? What's that? What's that? Falcon is disintegrated! Falcon is blown up! Holy crap, Falcon is blown up! Falcon is just disintegrated. Shit.
And we appear to have had a launch vehicle failure.
Holy sh...
Standing by for some information.
Holy crap. Well, at first I thought the stages separated, but that was no stage sep. No, I want to see this. We've just seen the
and
first...
the range confirmed that we have had a non-nominal flight.
First Falcon 9 failure.
Practice the rock and CityNet.
Wow, jeez. So, I'm presuming that means for a while Dragon is grounded? As well as Cygnus. Holy crud. There's nothing else to say. Yeah, I've... Oh. I'm going to see if I can re-watch that. Can't rewind. Wait. Sorry, I'm going to see if I can get some images of that. I'm sorry, I'm just going to plot back a bit. Come on. Let me rewind a bit. Don't tell me I can't rewind. No, come on, I want to rewind a bit. No. Holy crap.
And the range has confirmed the vehicle has broken up. It's not clear if the vehicle breakup occurred prior or after the range took their necessary precautionary action.
Does that mean that they're not sure if it was the range that blew it up or it was already blew up? You know, they activated the stop-destruct system. Okay guys, I'll end it here and I'll keep you updated through my videos as to what happened. Oh my god. That's the third rocket launch failure I've seen. And this... It was... Oh my gosh. Holy crap.
SpaceX is putting together their anomaly team to
This
put
is not
together
even...
what we do know at this point.
Well, I'll keep you guys updated through my videos. I'm about 2025. Goodbye, and holy crap. Oh boy.